to the Rhodes Weekly webinar. Today's webinar is going to be about building an application from scratch using RhoSync and connecting to a backend XML feed. This is going to be a first in a series of webinars based around this application. We're going to continually improve it and add functionality over time. So what we're going to be doing with this application is, in the Bay Area, there's the Bay Area Rapid Transit, and they have a wonderful XML API they provide. You can take a look at their website here at api.bart.gov, and they have information such as what stations are available and an example of using the API. And if we take a look at the source, we can see it's an XML data with a bunch of information about all of the stations. So what we're going to do is use RhoSync to pull out station information and display that on a device. And so we'll have an application where we can look up BART stations, we can look up the routes, and basically have a useful application if you're using BART. So the first thing that we do is we're going to sort of plan out what we want to do with this API and sort of how our models are going to look. So I've done this earlier. Open up text edit. So this is how I did it. Was I took a look at the API and decided, well, the first thing I'm going to do is have stations. So I went and looked through the API and I came up with this list. If we take a look at the API here, compared to the text document, there's three main commands that are used to get stations. There's stations, which gives you a list of stations, station access, which is accessibility information for the station, and station info, which is more detailed information. So I went and made this list. Let's see, make it a little bigger here. And this list, I've said, okay, well, we're going to need the name, the abbreviation, which is what the key is used by the API. So to get station access, you have to pass the abbreviation, so we need to store that value. Address, city, county, state, and zip code. From the accessibility API, there's instructions on how to get to the station, whether it has lockers, parking, bike racks. And from the station information, there's latitude and longitude, which I saw and I said, oh, this is going to be a great example of using mapping. So that's one of the features we'll add in another webinar, is integrating mapping. But we need to collect that data, so we're going to put it into our RhoSync source adapter up front. Intro, which is just a little blurb about the station, and cross street. And if we take a look at the BART's website here, we can see it has examples here of the different fields that are available and a sample. And there's more information that I haven't put in yet that I figured, it's really not required information for this application. So this is going to be my first model. This is the fields I'm going to have, is name, abbreviation, address, all the way through cross. And so it's always good to start by naming it out, because in RhoSync and Rhodes, you need to make sure that your fields are matched and that your model names are matched. So the second part that I needed was route information. What routes are there? Where do they start? Where do they stop? So I look at the routes and find, here's how the route looks, and it has a name, abbreviation, an ID, a number, and a color. And the color actually is what matches on the trains on what lines are actually running. So I went through the APIs here and came up with this next list. The next list here has all of the route information, And then there's more information in a second API called route info that has origin, destination, number of stations, and a list of the stations that are there. So if we take a look at the route info, you can see it has some more information and all of the stops on this route. So if we're doing route planning, we're going to need this information, so I'm collecting this information as well. The final piece of information that I'm collecting is based on schedules. If we look at the route schedules, you pass it in a route, and then it will give you the trains that are running on that route for that day. So it has a list here of all the stops, the times, whether or not bikes are allowed, and the station identifier. So I went through this list and again found the information that I'm going to need to collect. And so now I have my route stops model, which isn't going to be a model that's going to be displayed on the screen. I'm not even going to use the controller for it. It's just going to be used to look up information on, for example, if I'm looking at a station, I can say, okay, show me all of the stops that go through the station and the routes that are on there. And so it's really just going to be used as a lookup, not necessarily as something that's going to be displayed and it's going to have a view and all that. It's going to be generated, but we're not going to use it. So once we have all of our information about what we're going to do for our station, we're going to start our RhoSync application. So we'll make this a little smaller here. We've decided that we're going to have 3 controllers. So the first thing we're going to need to do is we'll add this to our webinar samples. This is our GitHub project. And so we're going to generate a new app called BART Server. In our BART Server, we're going to generate now 3 source adapters because we defined that we're going to have 3 models. We're going to have stations, route, and route stops. So we'll say RhoSync and give a list here. We need to say RhoSync source, and we'll call it route. And we'll do it again for RhoSync source station. And finally, we're going to generate the route stops. So RhoSync source route stop. Once we've done that, we'll open this up in our text editor. This is a standard RhoSync app. We have our sources, our spec, settings, and application RB. So the way you connect to the BART API is through XML calls. And since we're going to be doing that, we'll set up our requirements statements in the application RB, since all of our source adapters are going to share some of the same data and the same method calls. So we need XML simple and OpenURI. And we'll define some constants for our BART key. This is the public BART key they use for their examples. If you're doing a production application, you don't want to use this key because that's what they've reserved for testing. You can go to the website and generate their own key. And we'll have a constant here for our API. So we'll go ahead and save that. The first, we will implement our station. So in station, we aren't doing any login. It's not required to authenticate, so we'll just leave this blank. For query, since this is going to be a read-only application, all we're going to need to do is implement our query method. So we'll blank this out here so we can start. One of the requirements is that you fill the result hash with your details from the query method. So we'll start out with initializing that. And the first thing we need to do is get a list of the stations. So we're going to do XML simple, XML in, and then we're going to open and going to be our API here. So we have our BART API, which is the URL. This is the command we're doing, and we're going to be giving it our key. And then we're going to do .read. So since I know the format that the XML data is in, we're going to start with iterating through the list. This list here, you have the stations, and in XML simple, everything except for attributes is returned as an array because there can be more than one. In the BART API, there's one stations, so we'll give it the first one here, and then there's several station entities afterwards. So we're going to iterate through all of those. Since we have a station, we will define our object hash for it. And then we're going to capture all of the fields that we defined from the station API. We have name, abbreviation, address, city, county, state, and zip. And these are the keys here that is going to be matched in our roads application. These are arbitrary. I've decided on these because they make sense for the data that we're using. And the only thing that you have to remember is, since it's syncing the data, you have to have the same on the RhoSync and roads application. These are the fields from our XML station entry. And if we look at our notes here, there was a few more APIs that we're going to need to call to get the rest of our information. So from the station access, we're going to need to get the entering, lockers, parking, and bike racks. So what we're going to do is make another call here to the API. This time it's going to be the station access API, and it defines that you must pass in the abbreviation as the origin. So since we've already got the abbreviation from the last call, we put that in and provide it with our key. And then we're going to do the same iteration over the data to pull out the information that we need. So you can see there's stations that have multiple station entries in it. Because these are attributes, we're doing it without having to index the array. And we can actually go back and look at our API here. Go back to our station information. Station access has, you can see here, stations, which is where we start with. And then station has these flags, attributes on the XML node. And then it has several child elements. So what we're doing in our RhoSync adapter, these are taking the attributes, and these are taking the child elements. So we'll go and look back at our notes and see that there's still more information we need to get from the station, and it requires another API call. So I have that here. And we'll put this information in. So this is very similar to the last call that we had done. We're making another XML call and giving it the station info command and passing in the station abbreviation. And then we're iterating through the XML node and saving that data. So now we've collected all of the data that we needed for our notes. We're going to go ahead and save that into our result hash. And the way the result hash works is you give it a key field, such as an ID, that is a unique field, and then you pass it the hash of your object. So what we have is our key field for this is the abbreviation for the station. So we'll say our result station abbreviation equals station, since we built up this station hash, and that's all we need to do for our station API. You can see it's very simple to pull out all this information from the API and format it into a format that RhoSync uses. So let's test this and see how our source is performing. So we'll go to our spec folder, sources, station spec. So for should process station query, we're just going to go ahead and do test query, which will call our query method. And basically it will call the whole process as if a client has called up to the query. And then we'll just say inspect. So we'll output this as test query.inspect. Save that. So to run that, to make sure that we're getting from our API good, we're going to first start Redis. So we're going to say rake Redis start. So Redis is running. We'll go ahead and detach that to the background. And if we take a look at our rake tasks, there's a rake RhoSync spec that runs the source adapter specs. So we'll go ahead and run that now. So what happens here? We got an exception. It's trying to load station RB and it's getting a syntax error. So I must have missed an end or something in my station RB. And so, yep, I forgot to put the end on our first iteration. So I will save that and launch again. We can see we didn't do any tests for route and route stop yet, and then it gets to station, and now it's running the test. So it's calling the XML API, and so for each station, it's going to be outputting the station information. Is going to then make 2 more XML calls, so this could take some time. We see it went and it took 21 seconds total. And now you see it dumped out all of this information, which is our result hash. And you can see it has 24th, which is our station. And then it shows the data that it has pulled from the API. So what that means is we now have one API that is done and working. We need to go ahead and implement our other methods. So we'll go to our route RB, and I'm just going to paste in what I had done previously. Since this is basically identical to what we had done in station, except we're just doing it on a different information. So we'll save that. That doesn't look quite right. Have an extra query method there. Let's try this again. Okay. So what we see here is we have our routes. It's calling a different XML API, parsing the API. And when I was developing this, I literally started with station, worked out how I wanted to pull the data out, copied that in here, and then just modified the keys and the API methods for the data I'm looking for. One extra thing that we're doing is we're taking the array of stations and putting it into a comma-separated values. And that ensures we're keeping the ordering properly. There's several ways you can do this. And I've just decided is I wanted to store it as one data in comma-separated format that I will then pull out on the client when I use that. So we'll save that and go to our route spec. And last time it output a whole bunch of information. So instead of doing an inspect, we'll just do a size. And we'll say there are this many records. And we'll go to our route spec and we'll put this in as well. There are that many records. So now that we've saved that, we'll go ahead and run our spec tests again. So now route came first. It came up with 10 records. So there's 10 routes. Station is running again, and that takes another 20 seconds or so. Let's take a look here and see what we've displayed. So there's 10 route records and 43 station records. And that took 23 seconds. So one thing that we're noticing is, it's taking a long time to pull this data from the API. At first, I had used RxML to do it, and thought that, okay, maybe RxML is doing a performance penalty, so I changed to XML Simple, and the time only sped up by about a second. So that means that the API we're hitting is what is taking the time and opening the connection and doing that. So that flags in my mind that this is going to be a good candidate for using bulk data. But first we just want to get an application that works. So we'll keep that in the back of my mind is an optimization that we need to do is to implement bulk data. But since we're not having several minutes, it's not mattering when we're on our application. It will work. It will just be a little bit slow when it's syncing. So since we've done that, we're going to continue and do our next source, which is our route stops. And again, this is just calling the same XML feed with different API calls. So we're just going to fill in our query method. It's going to get the list of the routes. And then for each route, it passes in the route number to this extra, this other command called route schedule. And you can see I copy pasted because I even forgot to change my comment here. So one thing, since this is pulling information and there's no real direct order of this information, we need to give some sort of unique key for RhoSync to use. So we're just going to generate our own key that's just an incrementing field. So we'll start ID with 0 and then increment ID as we go along. And you can see then we just do result ID is the stop. Because the information here is, for example, we want to know a route, so we'll do a ROM query on show me everything with this route number. Or we're interested about a certain train, so we'll say show me all the stops for this train. or we're interested in a certain station. Show me all the routes for the certain station. So this isn't going to be something recording the ID directly. We're going to be doing several searches on this, depending on how we want to use the information, which is typically when you have a lot of information like that, it's a good lookup to have. So we'll go to our spec, and once again, we'll just do an output of how many records it is. And we'll run our spec test again. So our routes are hitting the API. Now our route stop are hitting the API. So while that's running, we'll take a look at our route stops again. For each route, it's going to get all of the stops on that route. And we know because we see there's 10 routes. 10 routes are coming back. Each route can have multiple trains because trains on BART start every 15 minutes or so. So every 15 minutes a train goes by and goes through all the stops. So you have that list of stops. And then you have all the different lines and stations. So what this indicates to me is that the number of stops we're going to have is fairly large. And if we take a look at our data, there's 14,558 records of the various stops. So this is a fairly large data set. It's not, 4,300. 14,000 to me that's a significant number. For the roads framework, it's not a significant number, and 14,000 records is handled no problem. So once we have our tests done, we now have a route showing 10 records, route stops showing 14,000 records, stations showing 43 records, and it took about 50 seconds. The next part is now we have to have a roads application that connects to the front end. So in this folder, we'll go ahead and just start our RhoSync server, since we know we're going to be using it. We know our source adapters are good. We're going to start the RhoSync server, and now we're going to go to writing our roads application. So we'll open up our terminal here. We're going to rhogen our app, so we'll say rhogen app BART. And now we're going to define our models. Our models are going to be the same names as our source adapters and going to have the same fields that we used in our source adapter. So I have my list here. So I'm going to say rhogen model station. And then I'm going to type in all my fields here. Name, abbreviation, city, county, state, zip, entering, lockers, parking, bike racks, lat, long, intro, and cross. This is why we started with this list, because we need to make sure our attributes match. The next thing we have is our routes. So we'll rhogen model route, and then we're going to have name, abbreviation, route ID, color, origin, destination, num, stations, and stations.